So in this video, we're going to do some word problems together. I suggest having either your Desmos app on your phone ready to go or have Desmos open on your computer, because we're going to be using that for each of these word problems. There's also a PDF available to you if you'd like to print this out ahead of time so you can jot down some notes as we go. So in this example, a player is throwing a ball towards a wall that is 17 feet high, and the height is modeled by that equation, and our job is to determine if the ball is going to go over the wall. So here in my Desmos graph, I've put my equation for the ball. I've also put y equals 17. I'm not going to turn this on just yet, but this would be the y value of the wall representing that height. So the first thing we're going to look at, if I wasn't using the height of the ball, I'm going to come here and click on my graph and click on the vertex. You can see here that the highest the ball is going to go is 15.76 feet. So that is one way I can tell that the ball will not go over the wall. I could also turn on this y value here, and I'm going to zoom out just a little bit. So here you can see the path of the ball, and it will not reach this 17-foot mark, which is another way that I can visually see on my graph that we're not going to hit that height of 17 feet, so the ball would not go over the wall. And you can use the fact that the maximum height is just over 15 feet, so the ball would not be able to go over the wall. For example, number 2, an arrow is being shot into the air. We know our initial height is 5 feet. Our initial velocity is 55 feet per second. And here I have the gravity equation. And we're asked first how long it's going to stay in the air. So here I have my equation for my arrow graphed. This is the full view of the path of the arrow. I'm going to zoom in just a little bit so we can see this better. Now, this x-intercept here has a negative value. I do not want negative values for time. We are not in the TARDIS. We're not Doctor Who. I can't go backwards in time, so I can't use that. So what I'm going to do is start at time equals 0, where my y-intercept is, and then I'm ending at just over 3.5 seconds. And I know that it's seconds because it says feet per second. So here my answer would be 3.526 or 3.53 seconds. The next question we're asked is, what's the maximum height? So I'm going to come back to that same graph. I'm going to zoom out and I'm going to drag my graph so I can see the vertex. I'm going to click on the vertex. So the maximum height is 52.27 feet. And it reaches that at 1.72 seconds. My first value is my seconds. The second value is feet. So it would be 1.72 seconds and 52.27 feet. We're going to continue on with this example. The first thing we're asked is, how long is the arrow in the air after it reaches its maximum height? Well, I know from my previous question that it lands after 3.53 seconds, and I'm going to subtract the 1.72 seconds that it took to get to the maximum height. So here, what I've done is 3.53, right? 3.53. I just need to double check. Yep. 3.53 minus the 1.8, nope, 76 from the vertex, 7.2. Lord have mercy. And that was 1.81 seconds. So that was the x value from my vertex to the x-intercept that was positive. All right. Now, the next one says that there's a line of trees that's 20 feet tall, and I can only see the arrow when we are above that 20-foot mark. So again, I have y equals 20 because that's a y value for height, and I'm going to zoom in. So this is the arrow going up in the trees. This is the arrow above the trees, above the trees, above the trees, and back down again. So what I need to find is the distance between these 2 points here where my quadratic is above that 20-foot mark. So we need to subtract 3.14 minus 0.3. If you want to use all 3 decimal points, that's totally fine. I'm rounding to the hundredths place. So my answer here would be 2.84 seconds for how long we could see the arrow. Next example, we have an arrow that's getting shot off the platform of 15 feet above the ground, and it has a 75 feet per second initial velocity. So I'm going to turn off this y equals 20 graph, and I'm going to turn on my second arrow. So I'm going to zoom out a little bit. A couple things that I notice. My y-intercepts are different. I'm going to keep going up here. Our vertices are very clearly different. So this second arrow is going to go a lot higher. And if you look down here at the bottom, the red quadratic is the first arrow. The purple quadratic is the second arrow. So that second arrow is going to be in the air longer. One way we can tell that is by actually finding these x-intercepts and comparing them. It won't let me click on the purple one. There we go. So I have 4.88 seconds for the second one, and we had 3.53 seconds for the first arrow. So it's definitely clear, looking at the graph and looking at these x-intercepts, that the second arrow is going to land after the first one. Now we need to figure out how much higher the second arrow goes. So I need to examine these vertices, and I'm going to have to zoom out so I can see them both at once. So here's the second arrow. That has a maximum height of 102 feet. So I'm going to put 102.89 into my calculator, and I'm going to subtract that 52.27 from this one. So 102.89 minus 52.27 is a difference of 50.62 feet. Oh, okay. Now I need that tree line again. Sorry, we just answered this question. I was trying to figure out where I was. Okay, so now I need to do the same thing with the 20 here. I'm going to turn off this red one since we're not using that anymore. And I need to look and find how long, there we go. So I have 0.07. So I have 4.62 minus 0.07, because I'm subtracting those two x values. So I have a difference of 4.55 seconds that we would see that arrow above that same 20-foot tree line. And then last but not least, we're tossing a coin off of a bridge into a stream below. This equation models the coin as it is above the water. So these output values represent the space between the coin and the water. So I want to know the greatest height of the coin, so I need to find the vertex. So here's my coin equation. I'm going to zoom out a lot. So here's my vertex. So the maximum height of this coin is 256 feet, which happens at 3 seconds. And then the coin hitting the water is an x-intercept. So again, I have to pick the left one because it's positive. So the coin would hit the ground after 7 seconds.